In this video, I want to evaluate quantifiers over special ranges, 1 point and the empty range. If I want to evaluate the quantifier over 1 point, all we need to do is look at the expression evaluated at that point. So there exists n equal 5 odd n is equivalent to odd 5, which is true. For all n equal 5 odd n, it's also equivalent to odd 5. Sum n equal 5 of n square is 5 square, which is equal to 25. Product n equal 5 of n square is also equal to 5 square, which is 25. Now let's look at defining the quantifications over an empty range. We define them as there exists over an empty range is defined to be false. For all over an empty range is defined to be true. Sum over an empty range is defined to be 0. And product over an empty range is defined to be 1. Why? Things should make sense. Well, notice if we were trying to split a range, any range is equal to itself or the empty range. So these definitions should make sense as far as split range is concerned. So let's look at them. If I want to split there exists an n in some range of for some predicate, I could write that as there exists an n in that range for the predicate, or there exists over an empty range, because the Boolean operator for there exists is disjunction or. Notice, though, from or simplification, that any expression or false is equivalent to the original expression, which means that it makes sense to define there exists over an empty range to be false. For all corresponds to the Boolean operator and. And simplification tells us that any expression and true is equivalent to the expression, which means that it makes sense to define for all over an empty range to be true. Sum over an empty range, well, sum corresponds to the operation plus. And any number plus 0 gives us the original number back. So it makes sense to define the sum over an empty range to be 0. And product over an empty range makes sense to be defined to be equal to 1 for the same reasoning. Now, one last thing I wanted to make comment about is that sometimes we'll see a quantification where the range is not given. That does not mean that we're dealing with an empty range. Often in the literature, if the range is not given, it's assumed to be the largest range for this problem that makes sense. And in our case, it's often any integer. But I just wanted to bring to your attention a missing range does not mean an empty range. Now this concludes the section on quantifiers. You're going to be wanting to be able to simplify them, evaluate them, and also you're going to need to change English specifications into quantifiers or quantification forms in our future work.